All right, welcome to another IAEI News Live. My name is Thomas Dimitrovich, and today we're going to continue the discussion that we had last week. This is a recorded session, so keep that in mind, but I will try to be monitoring the chat based on from wherever I'm at. But we're going to continue our discussion on lighting and the NEC. And you know what? It all starts now. Okay. All right, well, welcome back. And we are going to continue. It's been a busy day. We are going to continue, hopefully everybody out there as well. Hopefully that you are watching this and you are safe and healthy and ready to be a sponge and provide your comments and feedbacks. Remember, you can comment on these videos. If there's something you want to share, if there's information you would like to share, you can add those to the notes down below. And remember to subscribe to this YouTube channel. We are pushing the envelope here because I want to appreciate we've grown our YouTube channel membership greater than what it was when we started our adventure together. So I really appreciate everybody out there chipping in and just simply hitting that subscribe button. And hit the bell because you will be notified when we go live. And this is a video that is premiering because it has been pre-recorded. So unfortunately, I was not able to be with you live today. So I want to make sure that those events are few and far and in between, because I get more. I enjoy communicating with all of you out there. But please, leave your notes down below. Comment on this, whether you find it on LinkedIn, Facebook, YouTube, wherever else I'm putting it out there. So if wherever you find it, please comment. All right. So if you recall, last week we started our discussions around lighting, and we went through. And I say lighting and the NEC. Remember, it's the luminaire. Remember, we talked about what a luminaire is. We talked about what the differences are between the light fixture and all that jazz, and between what a light fixture is and what a luminaire is. We went through. I'm just looking back through some of the slides from. We went through the fact that the reason we all focus on lighting is because it's a big portion of our energy consumption, and I think, in my humble opinion, out of all of the types of electrical equipment that we work with, lighting is on that edge with regard to technology. It's absolutely phenomenal, the amount of change that we have seen in the lighting industry. And for the most part, the National Electrical Code, I mean, it has recognized some of those changes and it has not recognized some of those changes. And it is on the verge of continuing the journey for proper use and application of the latest that technology has to offer. I mean, what we can do today is mention, and I look up there because she's listening. And it's not Bobby Joe, it's not my wife. It's that little round disc that's sitting there, and she has a name. And when you say her name, you can follow it with a command, and by gosh, I can turn a light on and off, even upstairs or wherever it is in this house. I can turn it on and off just by talking to this little round disc that's sitting up above me here, waiting for me to say her name. We've seen LED technology. We've seen fluorescent technology. We've seen many different technologies occur in how we create light and how we control light. And now the code is trying to address, we'll get rid of that because I know you've already subscribed. And if you haven't, you are going to. So the code is adjusting to help recognize the energy usage and recognize all of these latest, newest technologies. In the 2023 code cycle, we're still talking about the latest technologies. So that's what I want to continue our discussion. I'm just looking through. We talked about the definition of track lighting, lighting outlets, what a lighting outlet, what festoon lighting is, what the electrical discharge lighting is. We talked about outline lighting. What else did we talk about? The luminaire and all the fact that luminaires have to be listed solutions. We showed you some pictures where listing is probably questionable on whether or not it's a listed product. I have seen people take, I've seen them take, and I've seen it in the electrical industry, right? How many of you have seen those watt-hour meters converted over into lamps and whatnot? If I was going to install that and inspect it, it probably wouldn't meet the latest version of the National Electrical Code. But then it's a lamp. It's not a luminaire that you would be putting into a lighting outlet, right? That's something that would plug into a receptacle, but a receptacle outlet. So in any case, we talked a lot about the listing. We showed you some luminaires that are questionable on whether or not they were obviously created. We talked about the location of luminaires. We talked about the fact that many of these luminaires will tell you exactly what can and cannot be installed inside. So we showed some pictures of here. We showed these pictures here. Where's it at? Teach. Boom. We showed these types of photos where it tells you what lamp that you can install in these. We talked about these, the lamping of the various types of luminaires. What you place in there may or may not be appropriate. So you've got to make sure you read the instructions and the labels to make sure that we're putting in the right solutions. All right. What is the other thing I want to do here? Well, let's take a look at this again. So what else have we talked about? We talked about the fact that we talked about the fact that a lot of these luminaires are in locations that may need to be provided with certain types of protection. There's certain calculations that are made to make sure that the right amount of light is provided in a certain area. So I think hopefully you understand and you get the gist of the fact that lighting is a changing industry. And there are a lot of new technologies that we are looking at today. And as we explore some of these questions, then hopefully you understand that it's not as simple as we all may perceive. So in any case, let's talk about the next question on our list. All right. Are luminaires manufactured for track lighting inherently protected from violations of NEC 220.43b? If not, how are designers, installers, and AHJ, remember, is authority having jurisdiction to prevent violations of this section and misapplication of the products? So the first thing we've got to do, 220.43b. And okay, so just so you know, I'm using the 2020 version of the National Electrical Code. Mine is kind of beat, and I have been shamed on my mistreatment of my book, but no books were harmed in the creation of this video, but they did come away a little bit tattered and worn. All right, so 220.43b. So open your book to 220.43b, and if you don't have a copy of the 2020 version of the National Electrical Code, you can go out to NFPA's website and buy one. I'm just saying. So 220.43, the title of 220.43 is Show Window and Track Lighting. So now remember, we're in Article 220. So, and I always, I have to make sure that you understand. When you start to read, when someone says, this is a violation of 220.43b, you've got to get your head wrapped around what it is they're talking about. And you don't just simply read 220.43b. Before you even read a word that is in 220.43b, you've got to understand where you're at in the book. So 220.43 is show window and track lighting. 220.43 is in Part 2 of Article 220, which is titled Branch Circuit Load Calculations. So we know we are in Part 2 of Article 220, which deals with branch circuit feeder and service load calculations. We are in Part 2, which is branch circuit load calculations. And we are not in Part 2. We're in Part 3, feeder and service load calculations. So we're not in Part 2. I went too far up. So we're in Part 3, feeder and service load calculations. Part 1 is general. Part 2 is branch circuit load calculations. Part 3, which begins with 220.40, is feeder and service load calculations. And 220.43 is show window and track lighting. A talks about show windows, not what we're talking about. B talks about track lighting. So now let's read B. For track lighting in other than dwelling units or guest rooms or guest suites of hotels or motels, an additional load of 150 VA shall be included for every 2 foot of lighting track or fraction thereof. Where multi-circuit track is installed, the load shall be considered to be divided equally between the track circuits. There is an exception. If the track lighting is supplied through a device that limits the current to the track, the load shall be permitted to be calculated based upon the rating of the device used to limit the current. All right, so this question says, are luminaires manufactured for track lighting inherently protected from the violations of 220.43b? So my answer, so my thought, to remember, 220.43b is a load calculation. If a manufacturer, who makes track lighting is not thinking about 220.43b, guarantee it. So are luminaires manufactured for track lighting inherently protected from violations of 220.43b? I would say no. If not, how are designers, installers, and AHJs to prevent violations of this section? This section is a calculation. So to prevent violation, you have to do your calculation correctly. You have to understand the installation, right? You've got to understand the installation. You need to, from a designer and an installer perspective, and the AHJ, we've got to work together to figure out how to do the proper calculation for feeders and service load calculations. If you're using a lot of track lighting, you've got to think about these requirements that are basically every 2 foot of track lighting, you're adding an additional 150 VA. Why is that? Well, when you look at track lighting, these they're expandable, right? They can change. These devices are expandable, and you can put more lighting solutions on the track. So if I have a track lighting and where I'm putting those portable so here's the question. Do you call that a luminaire, or do you call that, you can't call it you can't call it a lamp because the lamp would be the device, the bulb or whatever that you put inside to produce the light. So I'll call it a luminaire because it is an assembly. And the way it's mounted and wired into the circuit is through this track lighting. And I could put multiple track lighting. If it's a 2-foot section, I could put multiple track lighting in there. And what they require is that for every 2 foot, you have to add another 150 VA to your load calculations. Not something the manufacturer can do for you. It's only able to be achieved through properly applying it and understanding what you're installing, the amount of this track that you're installing, and work that into your calculation. And the AHJ needs to look for it. If they see track lighting and they didn't see anything in the load calculation that addresses it, you got an issue. You got to go back and take a look at it. It may or may not impact the size of your service or your feeders, but someone has to account for the footage. So every 2 foot, 150 VA. That's how I'd answer that one. Number 4, historically, lighting loads in non-dwelling occupancies have been considered continuous loads when applying the requirements of 210. Oh boy, you know what this is. 210.20a. Do current lighting technologies impact the application of that requirement? Oh man. So if there was any one change, so let's go to 210.20. What? Oh, 210.20, not 220.20. Okay, 210. I was thinking 220.12. I was like, oh boy, because there's another issue there, and we'll get to it. 210.20a. 210.20a says, what is the title of 210.20 first? Remember, we're in overcurrent protection. Overcurrent protection in branch circuits. In branch circuits. And I believe it's part 1. And it is. It's part 1. 210.20 deals with overcurrent protection for the branch circuit and equipment. I want to make sure that it's protected from overcurrent based on A and B. And A is your continuous and non-continuous. And where you have a branch circuit that supplies continuous loads or any combination, then you have to take 125% of the continuous load, right? So this is making sure that the branch circuit and equipment are protected. Now, historically, lighting loads. So do current lighting technologies impact the application of that requirement? All right. Remember, now just think about in 210, you've got the overcurrent protection, but then the other part of this is your conductor minimum ampacity. So I'm going to throw 210.19 into this picture. Remember, 210.19 talks about branch circuits not more than 600 volts. A1 tells you that the conductors have to have an ampacity not less than the larger of A, where you consider the continuous and non-continuous given the 125 times continuous, or B, forget about the non-continuous and continuous and just apply your conditions of use factors, right? So the first one looks at the continuous versus non-continuous and ignores conditions of use. The second one ignores the continuous and non-continuous and recognizes the conditions of use. So whichever one gives you the larger conductor, right? So lighting, is lighting a continuous load or is it a non-continuous load? And how might technologies impact that? So I'll throw in the 210.19a1 discussion, 210.20a. Where else is this probably considered is in 215. 215 talks about 215.2, minimum rating and size, feeders not more than 1,000. Very similar language to what's in 210. And 215.3 is overcurrent protection, very similar to what we saw in 210. So it's not just 210.20. Now, another complicating factor just when you thought you knew you had the answer and you were going to say whatever it is you were going to say, you got to think about all the different ramifications. And I swear I'm probably missing. But 220.12, which is why the moment I saw 210.20 and I read 210.20 and in my mind I was thinking 220.12. And the reason I bring it up is because Table 220.12 changed in the 2020 version of the National Electrical Code. We added a note to the bottom of Table 220.12 that says the 125% multiplier for a continuous load as specified in 210.20a. Let's go to 210.20a. Remember, 220.12 is general lighting, okay? General lighting loads, non-dwelling occupancy, right there. And now this says the 125% multiplier for a continuous load as specified in 210.20a, which is right there. We just read it. I don't even have to go back and read it. Right here, 210.20a is included when using the unit loads in this table for calculating the minimum lighting load for a specified occupancy. Okay? So, that means that if I'm going to do that calculation in 210 dot, it's not 3, 210.19, it's 215.3, right? Then I would have to work out my VA per square foot for the lighting load. Now, okay, what is a continuous load? Let's approach. I know I'm bouncing around a little bit, but hopefully you can go back and think about what I'm saying in all of these sections. Think about 220.12, where the 125% is worked into the table. Think about 215.3 that says you need to do two different calculations. So make sure I got the right numbers. 215.3 is the ampacity, minimum ampacity. 215.3 is overcurrent protection, right? 215.2 is the one I'm thinking about that says you have to do a calculation first based upon the 125%, second based upon conditions of use, right? And if the VA per square foot already includes the 125%, do I need to back that out? Think about the sections in 210.20 for an example. But now let's think about what is a continuous load. Continuous load is a defined term. Continuous load is one that runs for 3 hours or more. So you've got to look at your lighting loads and say, will they operate for 3 hours or more? Now, you may have a discussion with a designer or an owner that says, I've installed these occupancy sensors that when you leave the room, the lights automatically turn off. And you can say nobody is in there for more than 3 hours. I don't know how I would prove that, honestly. When I look at the lights, my basement lights have been on all day because I'm in the basement. My upstairs lights have not been on all day, but they will be on all night, and my basement lights will be off because I'm not going to be down here tonight. In commercial applications, can you truly say an office is not going to have the lights on during the day? And they're not continuous loads, 3 hours or more. Lighting is a hard sell when you say it's not going to be a continuous, in my opinion. Remember, anything that comes on this channel is not the opinion of IAEI. It's not the opinion of my company, Eaton. It's not the opinion of NFPA or the two code panels that I sit on, code panel 2 and 10. What comes out of here was generated up here. No one else influenced it. not directly. Because I am influenced by what I learn and from whom I learn it. And what I've learned about continuous loads is that, especially when you're dealing with lighting, you can't really control unless you have specific lighting that say it's outside and you have controls on it, and you know that, look, these lights turn on for 2 hours at a time, and that's it. And you can show that. Then you could probably say, look, you can make an argument to who? The AHJ. That's who you have to convince. And it's not this guy's opinion. It's not anybody else's opinion. It is between you and the AHJ. These technologies exist. These are sensors, right? That sensor up there detects the occupancy within that room. But look, I can turn it on and I can turn it off and I can put it in auto. So it has the option to be on. And if I leave it on for more than 3 hours, it is a continuous load. It's hard, in my opinion, it's really hard to convince someone that lighting is not a continuous load. It is a burden to bear. I know probably many who have tried it, but then I would say there are many out there who have failed. So, but in any case, that's where my head's at in regard to this technology. All right. So, and I would say, to answer question number 4, question number 4, which said, do current lighting technologies impact the application of this requirement? I would say it could, but very unlikely. That's my opinion. All right, let's look at another one. In other than dwelling units, 210.23c permits 40 and 50 ampere branch circuits to supply fixed luminaires with heavy-duty lamp holders. Are heavy-duty lamp holders limited to incandescent luminaires? Are fluorescent, HID, and/or LED luminaires available with heavy-duty lamp holders? So, the first place I want to take you is 210.21. Now, 210.23 permits 450. So let's take a look at 210.23 first. What does 210.23? Where is 210? We know is branch circuits, right? 210.23 is permissible loads. 210.23 just happens to be in part 1. Part 2, like I said, in part 2 of Article 210, which is titled Branch Circuit Ratings. So 210.22, permissible loads, an individual branch circuit, it can supply any load for which it is rated, but in no case can it exceed the branch circuit ampere rating. All right, so that's basically what it says, and it says permits 40 and 50 branch circuits to supply fixed luminaires with heavy-duty lamp holders. Well, 210. Well, I'm sorry, I read 210.22. 210.23 is permissible loads, multiple outlet branch circuits. And C is from 40 and 50 branch circuits. So a 40 or 50 ampere branch circuit shall be permitted to supply cooking appliances that are fastened in place in any occupancy. In other than dwelling units, you can supply lighting units with heavy-duty lamp holders, infrared heating units, or other utilization equipment. So I can put a heavy-duty lamp holders. Now the question is, what comes in those lamp holders? Let's take a look at 210.21a. 210.21 is outlet devices. A is lamp holders. Where connected to a branch circuit having a rating in excess of 20 amps, 40 and 50 would be excess of 20 amps, it tells us that the lamp holders have to be of the heavy-duty type. Now, what does that mean? 210.21a gives us some guidance. That unit has to have a rating not less than 600 watts. If of the ad medium type, or not less than 750 watts if of any other type. Well, oh my goodness. What is that, right? Ad medium. The base diameter, the external thread is 29 millimeters. Our mogul base is 40 millimeters. Both of those are heavy-duty lamp holders. So let's take a look at the standard screw types. You've got an E10, which is a miniature, E11 mini, E12 a candelabra, E17 is an intermediate, E26 is medium, E29 is ad medium, E39 is a mogul base. Okay, let's take a look at the depth. Think I can do this? No. I think this is three. Nope. It's one. I had three chances, and I had three chances. Let me put me over here. Right, I had three chances to get this one right. Let's put me up here, and I screwed up twice to get to the third one, and the last choice was the right one, of course. So there is your depth of the cavity. And this is out of the standard. E10 miniature, E11, always your E39, your E29s, you can see inch and 5/8 is the depth minimum. Inch and 11/16 is maximum for the mogul base, and ad medium is 1 3/16. So let me get me out of the picture. This is your rating of the lamp holder. So your mogul base, your E39s, 1500 watts, 250 volts. Rating of the switchless lamp holders, 1500 or 2000, 600 volts. And then your E29 ad mediums are 660 watts and 250 volts. And if you remember the 210.21a told us 660 watts. So that's where that number comes from, 660 watts. Now, if I wanted to show you a picture of what we're talking about, this is what that would look like. All right, so you can see these bases here are of different sizes, right? And this is your big, and that's your mogul base type of lamp. There's again another comparison, right? So now, what did the question ask? Let's get back to the question. Are heavy-duty lamp holders limited to incandescent luminaires? And that's sort of what we were showing. And his question was, are fluorescent, HID, or LED luminaires or lamp holders? So let's go back, because I have this. This is a 120 watt E39 LED bulb. Remember, what is E39? Let's go back. E39 is a mogul base. So that would be a heavy-duty lamp holder. So E39 LED bulb, 13,800 lumens, 5,000 K replacement for fixtures, HID, HPS, metal halide, or CFL, compact fluorescence, high efficiency, 115 lumen watt, 360 degrees lighting, LED corn lighting bulb. Ooh, that device is unbelievable. But I believe it answers our questions. It says, the question was, are heavy-duty lamp holders limited to incandescent luminaires? And I would say no, they're not. We already showed you a solution. That's an LED solution. But in this journey, we've learned a little bit about the requirements. We've learned a little bit about definitions. So hopefully you got something out of that discussion. And we're going to move to question 6. Since NEC 210.23d prohibits branch circuits larger than 50 amperes from supplying lighting outlets, 210.23d. 210.23 is permissible loads, multiple outlet branch circuits, right? And we are in, still in part 2. Part 1 is general. .23 looks like it is in part 2, branch circuit ratings. So 210.23 permissible loads, multiple branch circuits. A is your 15-20 amp branch circuits. B is your 30 amp. C is your 40 and 50 amp. D, branch circuits larger than 50 amps. It tells us that these branch circuits larger than 50 amps, non-lighting outlets. So you can't put a lighting outlet on a branch circuit larger than 50 amps. I mean, it's going to be a piece of equipment. It's going to be a load. It's going to be a motor. And this is, remember, this is branch circuits. Okay, so what was the question again? Whoop. NEC 210.23 prohibits branch. Okay, does that requirement infer that all luminaires will be adequately protected by 50 ampere or smaller overcurrent protective devices? Well, no. I mean, to adequately protect something, you've got to go through a process, right? You have to. Does that requirement infer that all luminaires will be adequately protected by 50 amp or smaller? Well, it means that if you follow all of the rules, then it will be adequately protected. But if you don't follow all the rules, then it's not going to be adequately protected. And what is your definition of adequate mean? Right? So if I think about this type of an installation, you know, I have a panel board. I have a branch circuit that goes to a receptacle outlet over here. That circuit breaker protects the branch circuit that goes to that receptacle. It doesn't protect on what's this side of the receptacle. Right? And in this picture, I've got a connected number 14, 15 amp conductor that goes to this multi-tap outlet. There is a connected cord to this heater element here. This is an SPT2 cord to conductor. That circuit breaker is not protecting that conductor. That circuit breaker is not providing protection for that heater. If that was a lighting outlet and there was a lighting fixture, that circuit breaker would be protecting the conductors going to that lighting fixture, that lighting luminaire or the lighting outlet, but it's not protecting the light itself. So if you want shock protection, that breaker is not going to do it. You would have to do something different. When might I need shock protection? Crawl spaces, right? So crawl spaces, we added in 210.8, crawl spaces lighting outlets. GSI protection shall be provided for lighting outlets not exceeding 120 volts installed in crawl spaces. Now you'll say, well, Tom, that doesn't protect the lighting fixture. It protects the human person from shock. I agree. I agree with that statement. Let's go back to that question. Does that requirement infer that all luminaires will be adequately protected by 50 ampere or smaller overcurrent protection? And I can tell you what the overcurrent protection is there for, right? I can explain what parts of this circuit that overcurrent protection does provide protection for and what it does not. I can tell you that in 240.51b that these cords are not protected based upon by the overcurrent protective device, right? Because why? Because 240.5b1 says that where you have flexible cords or tensile cord or approval for use with specific listed appliances or luminaires, it shall be considered to be protected when applied within the appliance or luminaire listing requirements, etc., etc. So 240.5b1, because 240 is overcurrent protection. And I would say, well, how do I get the protection of the actual luminaire? How do I get protection of the attached appliance? So if it's not in 210, and I can't say it's 210.8, right? That's people protection. If I go to 240.5b1, because 240 is overcurrent protection, and you would think overcurrent protection of the luminaire would be there. 240.5b1, 240.5 B, branch circuit overcurrent. 1, supply cord or listed appliance or luminaire where flexible cord or tensile cord is approved for and used with a specific listed appliance or luminaire, it shall be considered to be protected when applied within the appliance or luminaire's listing requirements. For the purposes of this section, a luminaire may be either portable or permanent. So this protection of that luminaire has nothing to do with the circuit breaker. The circuit breaker is not there to protect that luminaire. The circuit breaker is there to protect the branch circuit that feeds that luminaire. The protection of that conductor is applying it within its rating. That's why if you go to 411 or 410, right? 410 is luminaires, lamp holders, and lamps. There is a requirement early on in 410. 410.6. In fact, there's only 1, 2, 3 sections before this one, and it says all luminaires, lamp holders, and retrofit kits shall be listed. And if you go to 110, or is it 90? I think it's 110. 110.3 is B. Equipment that is listed, labeled, or both shall be installed and used in accordance with any instructions included in the listing or labeling. So if you are applying this product, it is listed. If it is a luminaire and it is listed and you are applying it within its rating, part of the manufacturer's instructions, based on 240.5b1, it is considered to be protected. The circuit breaker is not there to provide that protection of that luminaire. The circuit breaker is there to provide protection of the branch circuit, feeding the luminaire, feeding that lighting outlet. Now, there has been cases where you might say, for example, you had a luminaire installed in a crawl space and someone died. Boom, 210.8 requirement. Okay, we get the justification to provide the additional protection based upon statistics. 210.12, you may say, I've had lighting luminaires that have caused electrical fires. and you go, well, where's the statistics? And you look at the CPSC data, shows you the statistics of fires, electrical fires that have occurred. In fact, AFCIs are not responsible for. I'm going to make that clear. AFCIs have identified products that are faulty and have led to recalls. Now, what I'm going to do is I'm going to walk you on how to find that. If you go to www.afcisafety.org, afcisafety.org, this is a NEMA site. And I haven't been out here in a while, so let's go to multimedia. Arc fault circuit interrupter success stories. Look at this. I'm going to put this in presentation mode, can I? No, it's a PDF. Protects from failing garage lamp. Homeowner built house in 2004. AFCI protecting lights for front porch and luminaires. We got to fix that. Disassembly of the light fixture, the luminaire. Showed the wires were twisted, which caused the wires to fail and arc. AFCI breakers averted disaster. I'm looking. And this is all free and accessible to all of you as well. Look at this. Decorative lamp caused fire hazard. An AFCI detected a series arc in a lamp before any damage could be done. Resident of an apartment complex experienced intermittent tripping on one of the AFCI breakers. Electrician discovered arcing between the light bulb and the socket of a decorative lamp. Let's keep going. Oh, and it just gets keeping better. 11 reports of defective fixtures. This is about 83,750. Thomas lighting, etc. The fixture socket wire insulating can degrade, leading to charged wires becoming exposed, causing electricity to pass to the metal canopy of the fixture. This poses a fire and shock hazard to consumers. They received 11 reports of defective fixtures, which resulted in the home's arc fault circuit interrupters tripping. No injuries were reported, so we helped a manufacturer identify a potential problem that could have been catastrophic. Here is another one, 8,000 units recalled. The fixture socket wire insulation can degrade, leading to charged wires becoming exposed, causing electricity to pass to the metal canopy. 2 reports of defective fixtures, which resulted in the home's AFCI tripping. No injuries have been reported. So you can go and find that straight from afcisafety.org. Okay, so I don't know why I have a picture of a motor during a lighting presentation, but I do, and it was very important for you to see it, apparently. There's a lighting fixture. Look at this one. These wires are a little bit charred. All right, so 210.20. Let's go back to the question. I want to go back to the question. I definitely want to go back to the question. I think it's right here. All luminaires be adequately protected by 50 ampere or less. 210.20D outlet devices, the rating or setting shall not exceed that of specified 210.21 for outlet devices. And in 210.21, this is your outlet device shall have an ampere rating that is not less than the load to be served for lamp holders and receptacles, etc. So I would say no, it doesn't guarantee anything. You've got to follow all of the different rules. And we just went through a lot of different rules. And we understand now how those products are. And we understand that A, you purchase listed products, you install them per their listing based on 110.3b, and those conductors, that fixture is considered to be protected, not because of the overcurrent protected device upstream. If you want additional GFCI protection, or if it's mandated based upon the location of that luminaire or that lighting outlet, then 210.8. Or you can elect to go above and beyond and provide GFCI protection. If it's in a room inside of a dwelling unit that requires AFCI protection, or a non-dwelling unit that requires AFCI protection, then you provide AFCI protection for that circuit. Or you can go above and beyond the bare minimum code requirements and provide that protection to help reduce the likelihood and severity. So you are controlling risk when you install things like AFCIs and GFCIs when they're not required by the code. All right, that was a long journey, wasn't it? Let's do another one. NEC 240.83 includes requirements for circuit breakers used to switch fluorescent and HID lighting circuits. Do these requirements apply to other equipment used to switch that lighting, capacitors, snap switches, dimmers? All right, so now we're getting into HID. And I'll tell you what, in answering this question, I actually learned something myself. Because why? I had to do my homework. I'll tell you where these questions came from. I'm sure you're asking yourself, where did he get these questions? I had a mentor of mine. He's still a mentor. I like to think of him as a mentor. And he lives in Alabama. When I first met this individual, I asked Mark Early. I told Mark Early many years ago. Mark Early was with NFPA. He's retired now. I was with him at a section, IAEI section meeting, and I was realizing very quickly that I had no clue about the code. And so I asked Mark Early, I want to learn the code. Can you point me in the direction of an individual that I can trust, that is knowledgeable, and who can teach me? And Mark directed me to this individual who lived in Alabama. He lives in the Birmingham area, Shelby County, Alabama. And his method of teaching was giving me a list of questions that I had to answer. And he would ask me things like, for example, on this channel, on this IAEI News Live, I did a session on terminations. And he asked me to do 2 hours on terminations. And I said, I can't do 2 hours on terminations. How am I going to do 2 hours on terminations? I mean, I'm landing a conductor under a screw. How much time can it take me to explain to somebody that you need to put it under there correctly? And I realized quickly that I didn't have 2 hours was not enough, because there's a lot to terminations. And we explored a little bit of that on this channel, and that material was directly from that individual. And then he asked me about lighting. And he and I had this discussion, and this material is a result of my mentor helping me understand lighting and the NEC. So that's where this question came from. And I had to dig and learn. HID, what does that mean? HID circuit breakers. We all know that there are circuit breakers that are labeled HID, right? And something is bothering me right now and I need to fix it. Watch. Ready? Circuit breakers. HID circuit breakers. So HID circuit breakers, and I'm fixing it as I go because I just have to. HID circuit breakers, 50 amps or less, circuit breakers rated 480 volts or less can be marked HID. And what it means is that they're suitable for switching high intensity discharge or fluorescent lighting loads. Did you know you needed a special breaker if you had fluorescent loads? On a regular basis, these circuit breakers may employ a different construction than the standard SWD circuit breaker in order to address high inrush current resulting from the lower power factor created by HID lighting. These circuit breakers also undergo additional endurance evaluation to demonstrate their ability to perform the switching duty. Now, okay, to show you, just to tell you how this, how your journey of learning impacts so much. When I learned about HID breakers, this was well after that. I was on a task group looking at Article 220, which is directly related to our discussion of lighting circuits. Article 220, Section 220.12, we changed the general lighting loads by non-occupancy dwelling, and we modified the VA per square foot. When we were in our task group work, the lighting industry talks watts per square foot. Why? I have no idea. Well, I think I know. Years and years ago, it was all incandescent bulbs, right? And we had unity power factor. When we started coming out with other technologies like fluorescence, LEDs, HID, etc., those devices don't have unity power factor. What does that do? That's a phase angle difference between current and voltage. When I switch when I switch these technologies, that switching angle, I can hit that current when the voltage is at a minimum and the current is at a peak, or when the current is at a minimum and the voltage is at a peak. When my voltage is low on the sine wave and my current is rising, because they are out of phase with each other, I'm at a lower voltage trying to stop the flow of current at a higher current magnitude. That is a challenge for a circuit breaker or any switch device. So whenever we test switches, we always test like circuit breakers at certain power factors. Well, if I'm on a lighting circuit, I need to make sure that my power factor angle, the difference between my two sine waves, is accounted for in how I test it. So a breaker with an HID marking on it means that it was tested with a power factor that you might see with this type of lighting technology. We test them for the number of operations, but that's the fundamental difference in how that breaker is tested. And oh, by the way, because it's marked HID, it's also the breaker that you would use for fluorescent lighting loads when you're switching them on a regular basis. So if I go to the UL standard 489 for circuit breakers, high intensity discharge lighting type circuit breakers, a circuit breaker rated 50 amps or less intended to switch high intensity discharge lighting loads on a regular basis, it has to go through other requirements and be subjected in this standard, be subjected to endurance tests 7.1.5 and the temperature tests. Okay. So here's what 7.1.5 tells us. Subject to temperature tests refer to after 999, 1,000, 1,001, 200, 2,999, etc. Operations of endurance. The endurance test shall be in accordance with endurance test 715, except that the load shall have a power factor in the range of 45 to 50%. And you might say, boy, that's unrealistic, but I'll tell you what. Go out there and look at manufacturer's information, and my gut tells me that the least expensive ones are in the 45 to 50% range. Fluorescent, compact fluorescents, some of those can be at 50%. So what does that mean? If my load, if the lighting guys on, when we were working on our task group for 220, we're talking about, 1.5 watts per square foot. The actual VA per square foot is twice that. It's 3 VA per square foot because the power factor is 50%. If it was 45%, it'd be a little bit more than 2 times. That's how you can determine that. So that's a key piece of that language in UL 489. Now in section 9.15.1, it says, a circuit breaker intended to switch HID lighting loads on a regular basis and complying with performance, HID type circuit breakers may be marked HID location category B. Now, what about these devices? SWD, we saw those a lot on circuit breakers, right? SWD, suitable for switching fluorescent lighting loads on a regular basis. These circuit breakers are evaluated for high endurance use since they will be used similar to a light switch. So SWD is good for fluorescent. So HID can be used on HID or fluorescent, but if you're doing SWD, you can use those on fluorescent lights. Switching duty rated breakers shall comply with the construction requirements in all of those types. And look what it says. Intended switch for C9 10.1. And there's where it says there's your endurance and your temperature, but I'm looking for the power factor. So that's multiple tested. The voltage for the endurance shall be 120, blah, blah, blah. And it tells you what you need to do. Switching to tended to switch fluorescent lighting loads on a regular basis and comply with 710 shall be marked SWD. So this was 710 too. The voltage for the endurance test shall be after the operation. Each circuit breaker shall be operated only close to. So there's nothing in here about power factor. Nothing in here about power factor that I could find. All right, so hacker rated. Now that's another marking you'll find on a circuit breaker. This is your heating, air conditioning, and refrigeration, not ventilation. HV, the V is missing. So it's heating, air conditioning, and refrigeration equipment. It no longer has a marking requirement in that regard. So, and I know it doesn't have anything to do with lighting, but this is another marking that you may see, but it's no longer used. So, does the NEC, other codes, or engineering principles require the same concern for incandescent or LED lighting circuits? And I'll tell you why the LED came up. And this was a question that I've heard before, especially on LED lighting. And I'm just making sure. Now we were on 7, so I'm not going to hit 8 because we're coming to the end of this session today. So let's take a look at the question on 7 was, do these requirements apply to other equipment used to switch that lighting, contactors, snap switches, dimmer switches, and or clocks? So on the circuit breakers, there are definitely those requirements. Now, when it comes to other types of switches, you have to read the manufacturer's instructions on the switch. Those will tell you what they're rated for. In some cases, and I had fluorescents in my basement, and I put some of those occupancy sensors, and it caused a constant blinking. And I found that I was using the wrong switch for those lights. I actually changed out my fluorescents to a different technology, and the problem went away. But the switch itself, in the manufacturer's instructions, told me not to use them with that type of lamp. So I would say that the requirements in 24083 don't apply to other equipment because 24083 is on overcurrent protection. If you are interested to understand the requirements for like a light switch or those types of technologies, then that would be following the manufacturer's, at a minimum, follow the manufacturer's instructions for the proper application of those types of technologies, with whether it be a snap switch, dimmer switch. Snap switches are snap switches. That's just an on-off. When you start getting into dimmers, things that may have compatibility concerns, you're going to want to reference the manufacturer's instructions. But remember, Article 240 is overcurrent protection. Hopefully that helped a little bit. So we still have more questions, and we're going to continue our discussion. We have question 8, 9, 10, 11. We've got 16, 18, 20. I've got a lot of different questions, and we may bounce around a little bit, but question 8 is going to get into LED lighting circuits. So for our discussion next week, possibly, if I don't have another contestant willing to go live, we will continue our discussion about lighting, and hopefully I will be with you live next week. So I really apologize about not being able to be with you during this call live, but hopefully you got something out of this IAEI News live session. And I hope that we all learned something a little bit today in this hour that we had together. So thank you for your time. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Please don't forget to subscribe and hit that bell. And we will see you next week on Tuesday at 12 o'clock p.m. Eastern. Same time, same channel. Take care, stay safe, and remember, please, do what you can to stay healthy. See you next week. Heading out.